Welcome back, student. In the earlier class, we have come to know about the brief introduction of carbohydrates, its importance in our day-to-day life, and its chemical definition. Today, we will learn about the classification of carbohydrates. So, classification of carbohydrates has been carried out on the basis of hydrolysis, on the basis of its reaction towards Fehling solution and Tollens reagent, mainly. So, carbohydrates are classified into three groups on the basis of their behavior on hydrolysis. Carbohydrates has been classified into three categories. So, number one is monosaccharide, which cannot be hydrolyzed further. Are termed as monosaccharide, and the carbohydrates which produces 2 to 10 monosaccharides on hydrolysis are termed as oligosaccharides, and the carbohydrate molecules which produces large number of monosaccharides on hydrolysis are termed as polysaccharides. Next classification is on the basis of a reaction towards the Fehling solution and Tollens reagent. If the carbohydrate molecules reduces the Fehling solution or Tollens reagent, then the carbohydrate molecule is termed as reducing carbohydrate or reducing sugar, and the carbohydrate molecules which cannot reduce the Fehling solution and Tollens reagent are termed as non-reducing carbohydrates or non-reducing sugars. So these are the two links I have provided here where the reaction of carbohydrate molecules towards the Fehling solution and Tollens reagents has been described. Next, monosaccharides are further classified according to the number of carbon atoms present in it, and already we have come to know that monosaccharide is a class of carbohydrate that cannot be hydrolyzed further. There are about 20 monosaccharides known to occur in nature, and common examples are glucose, fructose, ribose, etc. So monosaccharides are classified into two categories on the basis of presence of functional group in it. If the molecule contains aldehyde group, it is termed as aldose, and if the molecule contains ketonic group, then it is termed as ketose. Monosaccharides further classified on the basis of number of carbon atoms in the molecule. If the carbon number is 3 in the molecule, then it is termed as triose. If 4, it is tetrose. 5, then pentose. 6, hexose. 7, then heptose, and so on. If the molecule contains carbon number 3 and it contains the functional group aldehyde, then it is termed as aldotriose. If the molecule contains ketone group, then it is termed as ketotriose. Similarly, if the molecule contains carbon number 4 along with aldehyde group, then it is termed as aldotetrose. If the molecule contains ketone along with 4 number of carbon atoms, then it is termed as ketotetrose, and so on. Here some examples are given. Glucose, which contains carbon number 6. There are 6 carbon atoms and it contains the aldehyde group, so it can be classified as aldohexose. Galactose is a molecule which contains again 6 carbon atoms along with the aldehyde group, so it is again also a aldohexose. In case of fructose, it is seen that it contains 6 carbon atoms along with 1 ketone group. That's why it can be classified as ketohexose. Next, oligosaccharides. Already we come to know that oligosaccharides are the class of carbohydrates that yield 2 to 10 monosaccharide units on hydrolysis. They can be further classified depending upon the number of monosaccharide units they contain. First of all, the disaccharide, which contains 2 monosaccharide units, or we can say which produces 2 monosaccharide units on hydrolysis. Trisaccharides, which contain 3 monosaccharide units, which can be, or we can say that it can produce 3 monosaccharide units on hydrolysis, and so on. Disaccharides produces 2 monosaccharide units on hydrolysis, which may be of same or different types. For example, maltose. Maltose is the molecule which on hydrolysis produces glucose, 2 glucose units, while sucrose on hydrolysis produces glucose and fructose, which are different monosaccharides. In case of lactose, it produces on hydrolysis glucose and galactose, which are again 2 different monosaccharides. But in case of maltose, 2 same monosaccharides has formed on hydrolysis. Polysaccharides already we have come to know that polysaccharides are the class of carbohydrates that a large number of monosaccharide units on hydrolysis. So some common examples are cellulose, glycogen, gums, starch, etc. Polysaccharides are not sweet in taste, hence they are also called non-sugars. This is the example. Starch and cellulose on hydrolysis produces glucose and number of glucose. So in the next class, we will discuss about some important carbohydrate molecules and their structures and their preparation methods. Thank you.